When I was growing up, I really loved the musician John Denver. And as some of you may know, he passed away in a plane crash about 15 years ago. And one of the reasons that led to his planes crashing is that he had to turn around to be able to operate one of the switches in his plane. And so there was a really simple usability failure that led to John Denver's death. Here's another example. This is a emergency telephone by the beach. So if something really bad, like a tsunami is happening, or a health issue, you're supposed to dial 999. The rub is that that telephone only has the buttons 1, 2, and 3. And so there are instructions on the bottom of the phone explaining on how you map the numbers 1, 2, and 3 to meet 999. And this covers my basic thesis for the entire talk, which is that really great design is difficult, requires use of training, requires lots of talent. Doing pretty good design as opposed to catastrophic design is actually pretty easy. And what I'd like to do with our time together this afternoon is to try and show you how. This is going to be real familiar to at least some people here who I've known for quite a while. And other people here, this may be really useful. Feel free at any point in time to jump in and ask questions. I just rejiggered some things based on our conversations, and so this time is for you. It's not just the major problems like death where design can really help. Let's say that bad design, the confusing checkout item or the ATM machine costs 10 minutes a day per person. Just in America, if you add 10 minutes a day per person, that works out to something like 3 billion person hours a year. And I think that is a huge figure with which we could use for much better purposes than just trying to figure out how ATM machines work. So if you can either reduce catastrophic error or even just smooth the path, there are big wins to be had in aggregate. Since this is an NHealth workshop, I'll start with a mobile example. This is from Omnitrax. It's a Qualcomm company. And they had made a mobile input system for truckers. They noticed that many truckers were not using the mobile device. And when they did, they always gave exactly the same responses, regardless of the situation. They rode along with truckers, and what they saw was that, and this is not shocking, but I think many transformations from bad design to good design are, at least in retrospect, not shocking, is that the many truckers have large hands, and on top of that, they wear gloves. And if you have a small mobile device with tiny physical buttons, they were hitting whatever sequence of buttons would let them get through and move on to the next task. So the redesigned version leverages a touchscreen where there are several common inputs that are on large virtual buttons. And you can hit those with a stylus if you're holding gloves, or with a finger if you prefer. And I think that's why the famous philosopher Yogi Berra said that you can observe a lot just by watching. That's the first major design insight that I think all of you will be able to benefit from. What we're basically talking about here is a lightweight version of anthropology. This is the famed anthropologist Bronislaw Malinowski. He was hanging out on the Trobriand Islands when World War I broke out. As an Austrian citizen, he would have gone to internment if he returned to Europe. And so he spent a number of years and developed a lot of what we know as modern participant observation. What we're looking for when we spend time with current and potential users and other stakeholders is, what do people do now? What are their values and goals? What do they want to accomplish? And how is the thing that we're working on embedded in a larger ecology? You can think of that as if we're designing a mobile trucker input system, It will be embedded in the how much time is available for that situation. Are people wearing gloves? All sorts of other stuff. So I wanted to give some really practical tips. When you are spending time with users, pay attention to all of the physical artifacts that they have around them, and just take pictures. My favorite ways of looking for redesign opportunities are to look for workarounds and hacks. Like here's the golden rule number one of design: look for post-it notes. If you look at or things that are taped over, any photocopy machine, fax machine, elevator, AV systems nearly always have a post-it note somewhere on them or something that's taped over. Those are great opportunities for redesign because they express what people wanted to do that was difficult to do in the current system. If you spend time in hospital emergency rooms, lots of workarounds and hacks of this sort. When people make errors, usually that reveals something about the design. Certainly some of the times that people make errors, it probably makes the most sense to say that the users were dumb, but the more interesting question for me is not are the users dumb or not, but if we had designed the thing differently, could that error have been avoided, or could we have a more felicitous experience that we created? And one thing that I want to safeguard against, we think about Malinowski, who spent his years hanging out with the locals. Here's an example from Walmart where they asked people about 5 years ago in a survey, would you prefer the Walmart store if the aisles were less cluttered? And what do you think the answer was? You see, yes, right? People said yes. So you ask people, do you want less clutter? The answer is yes. So Walmart, to great expense, decluttered its aisles, culled about 15% of its merchandise, and lost several $1 billion in the process. And I think part of the story here, I think there's several things going on, but part of the story here is that what people want, which is their behavior, is different than what they say they want for a variety of reasons. And so one of the great powers of the behavioral sciences, psychology, sociology, anthropology, is that we generally measure what people do rather than what they say they do. I think the health sciences know this at least as well. By contrast, here's a really great success. This is one of the very first consumer digital cameras. For the first time, for less than $1,000 in the late 90s, consumers could buy a digital camera. And it was a wonderfully easy-to-use interface for the time. One of the very first. So how is it that this user interface got created? Here's something that I believe all of you are going to do in some form or another this week, and that's create a prototype. This particular image is from the design consultancy IDEO, and what you see here is a prototype of this digital camera. Now what's cool about it is that do you see any differences between this camera and this one? Size, it's 2 to 3 times the size, a lot bigger. There's actually no camera in this camera. It's purely a prototype of the back of the screen. And one reason I like that image is that it points out that a prototype should not have to be complete. Prototypes are questions. You're trying to figure something out. With a digital camera, how the front part of the camera works is mostly similar to an analog camera. But how the back part of the camera works, well, that's quite different. And what I like about prototyping is that my experience has been you can kind of talk and talk and talk forever. And then when you get a fast prototype out in front of all of the stakeholders, whether it's your boss, your colleagues, the users, even yourself, you begin to realize things. So here's a workshop at SAP where they were prototyping smartwatch user interfaces. And everything that you need to do this activity was skills you acquired in kindergarten. So it's the markers and the Post-it notes and the paper, super fun, really fast. 20 minutes you can say, is this the kind of thing that you meant? And then you can move your design forward. And I think it's for this reason that prototyping is the pivotal activity that structures innovation, collaboration, and creativity in design. Designers use prototypes to embody their design hypotheses and get feedback from real stakeholders. When you create a prototype, it's never about the artifact itself. It's about the feedback that you get from that prototype. And you can do this stuff really, really fast. When I think about the prototyping process, what I think about is not what's your imagination of what the design will be, but what's the biggest question that you have about your design? And that's the thing that you'll want to prototype first to be able to get feedback on. And this is a variant of the move your risk all the way up to the front of the process so that as you get further along, you don't need to course correct as much. Here's another example. 2000, Palm sold nearly 8 million personal digital assistants. It was the first time that there was a device that fit in your pocket that sold well. They had a 76% share of the PDA market, and the design was really famously streamlined. So where did that come from? In this case, the journey to 8 million users began with a block of wood. The lead creator of the Palm, Jeff Hawkins, actually cut out a wooden block as a prototype of what the Palm Pilot would do. And so Jeff carried around a block of wood that looked just like this. It's now in the Computer History Museum. This is one of the more polished versions. The earlier versions were hand-drawn. And he would just try all of the activities that the PDA could do. You could look up people's phone numbers, enter calendar appointments, the whole shebang. And what that taught Jeff is that, up front, you can imagine if you're making a device like this for the first time, it's hard to know what things people will really do with it. It's even hard to know what you'll really do with it. And so you can use the prototype as a probe to try and catalog, well, what are the things that I would want to be able to do if I had a device like this? And I like that setup because it really is hard to know in advance. This is a sketch from my former student, Mike Krieger, who founded Instagram. This is this is the first time that they started to figure out at a scale level what the Instagram user interface might be. And so prototypes answer different questions. This particular sketch while it's a rough sketch, it's unitful. And so they're trying to figure out how will things lay out on the iPhone user interface. You can also think about the prototyping the back end. Or I think a lot of the most interesting prototypes are experience prototypes. So what will the experience be? And for that, you don't need the user interface to look right. You don't need anything to be built at all. You can use a strategy that we call creating a Wizard of Oz prototype. It's, the movie where the Wizard of Oz is behind the curtain. And so with your Wizard of Oz prototype, you can offer an entirely interactive experience. This is commonly done in speech user interfaces because having a human be the speech user interface is pretty natural. But you can do it for anything, ticket machines, whatever you want. Here's another quick example. This is the first cross-country jet airliner, and the person standing in the suit there is Walter Dorwin Teague, one of America's great industrial designers. What's notable about this airplane is that it's the entire airplane except the airplane. Just like the digital camera with no camera, in this case, Teague is trying to figure out what will the experience of traveling across country be. So they had passengers pack for a week-long trip, board the airplane, which is just an empty exterior in a warehouse. The airplane would take off. People would fasten their seatbelts. The staff would come through with food and drinks back when they had that sort of thing, and they would do the entire cross-country flight. Teague's contemporary, Henry Dreyfuss, did the same thing for cruise ship design. And so I think this is why the Nobel laureate Linus Pauling says that the best way to have a good idea is to have lots of ideas. That you want to be able to prototype lots and lots and lots of stuff. One of the great fallacies that we know about cognition in all fields is that people underestimate the variance of what's possible. This is true and recently relevant. everything from stock picking to designing the first mouse. When Microsoft put out the first Windows and was figuring out what mouse would accompany it, they made more than 100 physical prototypes. And you often have a sense ahead of time of what's going to work. At least in my experience, I'm nearly always surprised by what works best. And at the very least, this gives you a wonderful vocabulary for talking with other stakeholders. So, in short, prototypes are questions, and you should ask lots of them. I don't have time to go into depth today. If you're curious about this stuff, we have an online specialization on Coursera. All the materials are up there freely available, or you can pay and get a certificate. But everything I'll talk about today and lots more is up online at hci-class.org. So what I just added, based on my conversations before speaking today, is I wanted to give a little bit of concrete strategies for what you can do in terms of prototyping. By now, I hope that you'll believe that prototyping is a good idea, but I wanted to show some examples of how you might do it. And here's one of my favorite prototyping strategies that you can do really early on. This is called a storyboard, and a storyboard is something that helps you think through your design by taking you from a setting. In Amal's example here, this is what might we do on an evening out in San Francisco, to satisfaction, which is that you've achieved your goal. And what's cool about a storyboard as a prototype is that it doesn't specify yet, we'll get there of course, what the actual user interface or the details of any of it are. You can think of this as being a little bit like a spec for the user experience, that anything that got you from that setting to that satisfaction counts as a good user interface approach. When you start out with the setting, you want to explain who the people involved are. I think that a lot of people are accustomed to making some kind of wireframe of the user interface, and so often you think about just drawing a mock-up of the user interface. And what I like about storyboards is that they put the people in there. Shows the environment and what task they're accomplishing. And then you have a sequence, and this is a really high-level sequence. We're not yet at the level of select the fourth item from the drop-down and all that stuff. Just very high level, what happens, and then how do you get to the satisfaction. So, holistic focus, not a particular UI yet. And it's great because it gets everybody on the same page. One of the great challenges of design teams is that at the outset, everybody has a completely different thing in their minds about what the design is going to be. Again, here's some early sketches from Mike, the Instagram user interface, and these were instrumental, Mike tells me, in terms of getting the whole design team on the same page. Here's another example, really nice storyboard. And then what you can do with these, so once you've got your storyboard worked out, then you can start to create a paper prototype of the user interface. So these are the same materials as a storyboard. But now we actually are starting to think about how this lays out on screen. And here's a short video in the mHealth domain of what a paper prototype user interface might be. So here we've got the cards. This is a mobile phone interface, which is giving you some setup information at the start. You're configuring this, you enter your phone number, do a few other things, and this is going to give you some analytics, Fitbit-like stuff about what your day is like. And what's neat about this is as you start to interact with it, at first it's just flipping through screens, and that's fine, but you can actually build real widgets here, so you can have drop-downs or anything else that you might want to be able to do in your interface. In fact, because this is all just pen and paper, when you get to built software, if halfway through somebody says, ooh, what if it did that? You can't do that anymore. But at pen and paper, halfway through this experience, you could just change the entire UI by drawing whatever you wanted. You can even do complex visualization stuff in a Wizard of Oz prototype mode here. Really, really powerful. So when you're making storyboards and paper prototypes, work really fast, faster than you should. People often want to be too precise. Doesn't matter. Photocopy is your friend. You can make reusable components and widgets and all of that stuff. If it's hard to simulate or if you need it on the fly, you can just draw it right then and there. If you put things on the background, you'll see that the watch was on a watch and the phone is on a phone. That helps convey what it's going to be. And as you move, if you're doing a redesign or if you are moving from the paper prototype stage to something a little bit more formal, you can actually mix the paper UI elements with more formal pixel-like UI elements. You can stick Post-it notes on an iPhone or anything you want. And there's lots of stuff that you can do. So the reason to do all of this is to be able to get this out in front of people as soon as possible. Common design errors that everybody says, I want to get the design nailed down before I show it to people. Or even if you think, I want to get the design a little bit further along. And it's almost always valuable, I think with all creative endeavors, to get it in front of people a little bit sooner than you think you're ready. One nice thing about getting it in front of people a little bit sooner than you think you're ready is that you're not yet committed to that path. So if they're like, oh, it doesn't quite work yet, you're like, yeah, I know, I'm still making it. Mike Krieger, who made some of the sketches that you saw, for a number of years, he would have a human-centered design Friday afternoon, where every single Friday afternoon, he would bring new real users of the social computing platform that he was working on into their lab. And he would walk through new user interface elements. Every single week, he would try something new. And here's some more examples of really, fancy stuff that you can do with paper. It works really well. Because these materials are low tech, everybody involved in the design process can do it, and that's a big part of the power. And check on time here. I want to give you a quick example of one health-related project that we did in a human-centered design way. This was in collaboration with some folks in the Stanford Medical School, Larry Chu and Kyle Harrison. And Larry emailed me one day and said, hey, I think I do what you do only in the medical school. We started up a project for several years. It was really fun. What we were looking at was the challenge of crisis response, where by various estimates, between 50 and 100,000 preventable deaths happen in hospitals each year due to things like simple checklist errors. Yeah? Yeah, sure. All right, we'll put this, ooh, that's a lot louder. All good? Great. There are a number of different people here, which is part of the challenge. And they come from totally different backgrounds, have totally different cultures, hang out in totally different lounges. Emergency response is really tough. Often, people miss really simple things. So this was actually a training session where it's a simulation, obviously, you can see from the patient. And they've missed, even though they're demoing good practice, they've missed the fact that that bag is inflated when it's not supposed to be. This is for a relatively simple ergonomics reason, that all of the staff tend to be arrayed around the patient. And when stuff gets shoved in a corner, people often just don't see it. And this is the same challenge that we have with checklists, where they'll often, you start working on the patient and you may even hold the checklist at the beginning like you're supposed to. And then, things get hairy and you just throw the checklist away and all of the good ideas go away with it. So we were interested in both the opportunity for checklists, but also the challenges of getting people to use them in practice, especially emergency situations, as opposed to more routine ones. And we saw there were, so we spent a couple of years, and we actually followed pretty much the human-centered design process that I've outlined here, where every week we would meet with our medical stakeholders, and we would show at first sketches and storyboards and paper prototypes. Often we would design with them. Over a period of months, they got more and more refined, and we started to make them more interactive. And here are 4 of the challenges that we saw with checklists that we tried to overcome. The first one is that checklists are, in a crisis, difficult to find and difficult to share. You saw the one that was discarded, but even if somebody's holding it, only one person has that information. And the theory of mind problem in emergency response, where what's in my head is different than what's in your head, is a really big problem. Another one is that emergency response is so fast that it can be difficult to assimilate the information that you need from a checklist. And this means if you use it, that you may be dropping packets on other parts of the process. And if you don't use it because it's too slow, then you don't get the benefit. The third one that we saw, it was kind of interesting, is that there are some aspects of an emergency response team, like nurses, where protocol adherence is a big part of the training. There are other parts of the emergency response team, like specialty doctors, where protocol, like there's a little bit of a cowboy energy sometimes. And so people feel like if they're using the checklist, that's like riding the bicycle with training wheels. And so we wanted to have something that people didn't feel like they were being marked as dumb if they were using. And then the last one is that there's really limited attention in stressful environments. So here are some of the ways that we tried to address these. A lot of these are relatively simple, is that as opposed to having a personal sized device, we put 2 replicated large-scale displays, one on each side of the operating theater. Nearly everybody arrayed around the patient can see one of the 2, and because they know that everybody's got the same information, you can feel more confident that everybody knows what's going on. The other thing that we saw was we worked really hard to try and simplify the display. So these are the Brigham and Women's Hospital best practices checklists for a number of things. The graphic design is not great, even though the content is very good. A lot of the type is small. It's difficult to know what's where. We've run eye tracker studies with these, where you see that people don't know where to look. And so what we did is we streamlined a lot of the content, added icons where appropriate, and tried to integrate. One simple thing that you can do with digital displays is that you can integrate current state. Like if the current heart rate is part of the information experience, you can put that right on the checklist. And then these can reveal themselves over time. One reason that if you're working on paper is that paper is static. And so with a digital checklist, you can zoom into the relevant information, and that makes it easier. In this case, one big usability benefit is that a lot of the writing was overly verbose. And so we came up with a consistent and more stripped down language that made it a lot easier to see the necessary information. By putting the same information in the same place all the time, as opposed to using natural language, it really helped people find what they needed. And then we tried to integrate it into a larger system. And one reason for this is that if the only reason you're using the checklist is to remember to do a particular step, then it feels like training wheels. Whereas if it's reference material that is specific to your current context, then that's an advanced user dashboard, as opposed to I'm not really quite a doctor yet. And there's a real tension here between how much information you put on the screen and having it be readable by everybody that we spent a lot of time fine-tuning. This is one of our earlier designs that I think is still a little bit too complex. But getting that real-time information there makes it seem like a cool, fancy thing as opposed to a dumb thing. So the last thing that we found was that because people have limited attention, and this is especially challenging in crisis response, where you alternate between hours of boredom for many of the participants and moments of extreme terror. Flying an airplane absolutely has that attribute. And so what we could do is there are some simple things like have the interface scroll along automatically. And for things like drug timers and attentional prompts, the checklist itself can time the space between epinephrine doses, for example. And so it can give you the information that you need at the right moment in time. And this was the interface that we ended up with, where it would zoom in to the particular spot that was relevant. This is what's known as a overview plus detail or focus plus context user interface. The last thing that I wanted to share about this project was one of the ways that we studied its efficacy. We had a challenge that I think many of you will be familiar with in the medical world. It's really hard if you want to have authentic experiences to be able to compare across participants. And so often what people do is you either move to more the laboratory psychology model, where you give something that's really stylized and not that relevant to expert practice, or you go the in situ model, but then it's very difficult to compare across people. So what we did is, with our collaborator Stu Card, we created a strategy that we call narrative simulation. I'll show you what it looks like. Here's a scenario, and it's inspired by existing training materials. So participants see a scenario, and it goes along at about this clip. And so you have, this is like a choose your own adventure. You'll see some information, you'll get some statistics, and then you get asked a question. And when you get asked the question, like what is the rhythm in this case, you respond out loud. And you get 5 seconds to do that. At the end of the 5 seconds, it provides the answer and gives you your next step. And so in this way, what we have are real scenarios in a way that is comparable. And that's important because if you want to be able to ask the controlled experiment question of how well do people perform, this is how the doctors performed without any cognitive aids or checklists. Paper improved things a negligible amount. And we saw a big uptick with the dynamic aids. And so what I think is neat, we did a bunch of other studies too, but I wanted to show this one today as an example for how you can do actual controlled experiments before you've written any software at all. This was done on a user interface design prototype. And because we know what all of the prompts are, we don't need to write any code before we test the efficacy. And I think that's important because if you spend several person years developing even a first version of the software, and it turns out that you've got some assumptions that don't work out, then you're in big trouble. And so test earlier than you think you should, both in informal and in informal ways. I think design right now is at a really interesting moment, and I'm going to end early so that we have time for questions. I think that'll be good. And I wanted to close with some thoughts about where design is heading. That in the 90s, with a desktop computer becoming pervasive, trying stuff out with people was basically, in Silicon Valley, folks would build their software. When you get it mostly done, you bring somebody into the lab and you watch them use it. If you're fancy, behind a one-way glass mirror. If you're a startup, just at your kitchen table. When they get stuck and swear, you write down what happened, and then afterwards you fix the usability or software bug. And then you bring somebody else in, and when they get stuck and swear, you do the same thing. And then when you run out of money or time, you release it. And once you've released it, you have no idea what anybody does with your software. In the web age, we had the opportunity to release early and often, the joke that all web software is in perpetual beta. And also we have the ability to run controlled experiments and see what people are actually doing afterwards. So it's not just you bought it, who knows what happened. It's, well, these are the things that people are using. We can see where people get stuck. If we change this variable, then this happens. As many of you may be aware, on any given day, there are half a dozen or more experiments that Amazon and Google and Facebook and all of the top web houses are running on their content. And the power of controlled experiments is showing up everywhere from search results design to e-commerce to political campaign messaging. And this shift I see as, I call it design at large, that you're moving from the more controlled environment and you're moving out more into the ocean. Now, when you're creating designs that are more research-oriented, and you know, many of you here are researchers, so I'm telling you what you do already. I found this to be a valuable way to communicate it to others, that I think about a research prototype as kind of like creating a postcard from the future, that you're imagining some particular future, and like a traveler, in this case you're a time traveler, you're sending postcards back to the rest of the world through your research prototype. And so the role of research in inventing the future is that we get to live in the real future before the future actually appears, and we can give advice to the rest of the world on what it's like to live there. And so the goal of our design lab at UC San Diego is to be able to build practical theory with real-world experiments, and then bake that theory into software that transforms all of the domains that we work on. I do a lot of work on active learning. I have several colleagues in human-centered healthcare design. And I'm sure preaching to the choir here, this is a real multidisciplinary effort. So our lab has folks from computer science, let's see, ubiquitous computing, computer graphics, product design, visual arts, cognitive science, psychology, a math PhD, theater and dance, and actually in the bottom right, a surfboard designer. So there are folks from all over campus that are involved in this. And I think for all of you that work on interdisciplinary projects, you get what the power there is. It's a lot more fun. It's a lot more interesting. Here's an example of one of Eli's projects where he's been working on human-centered healthcare design in Mozambique and other places. And he's a doctor by training. And we brought him into the lab because when our director, Don Norman, and I wandered by one day, the only book he had in his office was Don's The Design of Everyday Things, which is a great book that I highly recommend. And Eli was thrilled that Don was in the same building. And so he's been working with us on a number of projects. And you can find more about what our lab is up to here, and I'll be happy to take any questions.